Uh, Hello everyone once again. We are for the data structures and algorithms series where we study together until we crack a job. Okay, so today I welcome you all to this. I believe today is day 7. Today marks 1 week of our journey. We started on Tuesday, last Tuesday. So that was, I believe, today is what, 28? So we started on 21 or 20, I believe. And it's been a good journey. So yeah, we started on 20. We started on 20. So today is 28. So it's 5 plus 2 days to today because we do from Tuesday to Saturday and then from Tuesday again. Today is what, day 6, and I welcome you all to this data structures and algorithm series. Yesterday we were on the cusp of doing and finishing arrays. So let me just show you here that it's the green marks here. And there were some questions that were not from the topic right now because some were of BFS and DFS, advanced BFS and DFS, and some were of questions on DP. So we are skipping that for now, but for unless all, we did everything. Okay. And this, as you can see here, let me just show you guys. Okay. So we were left with these questions, that is a three-way partitioning, maximum points of cards, maximum area of cards, number of zero field subarrays, increasing triplet subsequence, and all those questions. So we were left with all these questions, but alas from that, we were completed on arrays. Okay. So we were now left with questions from strings. We were now left with questions on hash tables, then two pointers, then sliding window and linked list and all those kind of things. Okay. So we are going to continue with the same, and the question that you may ask is a valid one. When are we going to, revise it? So initially, our thought was to, revise these today, but I thought that we can, more can centralize ourselves on. I believe we can centralize ourselves on practicing more. So those we can actually, improve ourselves on answers, not just rash driving into anything and just keeping answers. So what I will do today is I will make a folder here uh, in the master sheet, and I will combine all these questions inside the arrays one. And right, and once we do all the string questions, then I will merge all these questions including the reverse string one into the arrays folder, so that way it will become much more cleaner, right? So we will combine all these questions from master sheet into the arrays folder, and then we can do all these on this. Now comes the revising one. So once we are done with all these questions, we are going to revise everything. Okay. Our target is to just complete strings first, at least as far as we can do in strings. And thus I can see that we can choose maybe Friday and Saturday. Okay, so today is what, Wednesday. Yesterday was Tuesday, so we will do strings for today and tomorrow, and for day after tomorrow and day after tomorrow we will do revision on arrays and what kind of questions we did till now. So Friday and Saturday is going to be about revision, and from next week we are going to continue with this with more questions altogether. Okay. So today we will be continuing with strings. Tomorrow we'll be continuing with strings, and we are going to continue ahead with our work until we are more confident in ourselves. Okay, so let me just. We will be starting with strings today. So hats off to everyone who has stick till now. And tomorrow we will be doing strings as well. And from Friday and Saturday it will going to be just pure revision. Friday and Saturday is going to be what, pure revision. It may be a short lectures because 5 hours of revision would be good, but if we revise that beforehand, then it will be good for us. But if not, then Friday and Saturday is going to be what, pure revision, pure revision, nothing else. All right. So I guess we are pretty clear on the terms of what we are presenting ourselves with. So good, right? So let's just not waste time because it's what, 5 minutes we have already crossed, and let's just solve more questions. Let me just, okay. Okay. Video capture device, yes, this one. So let me just short screen myself. All right. So let me just, okay. So let me just do the master sheet into the code space here. Open everybody, GitHub dev, Google clone, GitHub dev. Okay, so let me create a folder called arrays. All right, where is the arrays folder? All right, and we are going to create everything. Okay, and how are we going to select everything? Uh, all right, and shift this. All right, and once we did this, we are going to control and paste here, copying 40 folders. All right, so we have what? We have added everything. Hmm? And let's just see that 3227 3227 3227 here. 3227, 3227, 3227, 3227, 3227. Mira. Okay, so we have worksheet, uh, discard changes. Okay, so we're going to do this. All right, so we added everything, I guess. Two sum is left, so we are going to add two sum here as well. All right, two sum into arrays, move. All right, so now we are left with just deleting everything. And all right, so I believe that should have worked. I don't think that should have worked really well. So how do I roll back everything? Okay, let's roll back everything. Okay, let's roll back everything. Discard all changes. Okay, and discard all 88 files. This is irreversible. These files will be lost. Hmm. 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 All right, so we have everything. Uh, you know what? Let's tell the agent to do the work for us. हमारे पास बहुत क्रेडिट बचे हुए हैं अभी भी. हमारे पास बहुत क्रेडिट है. देखो ना कितने क्रेडिट है अभी हम पे. एजेंट को बोलते हैं सारा काम डाल देगा. Okay. Make a new folder called arrays and put all these folders inside inside that. All right. तो जब तक ये काम कर रहा है हमारा तब तक हम नेक्स्ट पे चलते हैं. आज हमें स्ट्रिंग्स करने हैं. तो we did reverse string yesterday. If you don't know reverse string, so we were doing swapping in this. So today we will be doing a new question. Okay, let's do this. Yesterday this was the question of minimum height question. Okay, today we will be doing. All right, Control P. All right, so today we will be doing What should we do? What should we do? Reverse string. Let me just show you reverse string. All So this was a reverse string question. It was a pretty easy question. We will use two pointers here directly and use the swapping logic to directly swap characters. Okay, so this was the two pointer question. We were using the swapping logic to directly, swap some characters. So we were given with int left 0. So we have the left pointer and then we have the right pointer. Okay, and the left pointer was at the starting of the character index, the character array, and then we have the right pointer on directly on the very left right side. Okay, so while left is less than right, so what we can do is we use the character temp as the character on the left side, then we have left is what is equal to right, and then what right is okay, so cancel, and then sorry, and then what left is going to be equal to right, and right is equal to left, and left plus right is minus. So this loop will run until left is going to be less than right. And yeah, this was a reverse string question, pretty easy one. Okay, so pretty easy question. So next question today we are going to do is a valid palindrome question. Okay, it's a good one. So we will doing a valid palindrome. Okay, so this was a valid palindrome question. Let's do this. Hmm. Valid palindrome. All right, let's do a valid palindrome. Oh, my voice goes down. Yeah, let's do a valid palindrome. I'm sorry. Okay, so let me just bring up the music as well. So this is a valid palindrome question. Question is very simple. We have to check that if it is a valid palindrome. Okay, so if the right side is going to be equal to left side. Okay, so a palindrome is something. For example, let me just tell you of something of a integer one. Okay, so let me just zoom things. Okay, so that you can see. So for example, we have a number called 1 1 1 2 1 1 1 1 1. Okay, so we have four ones here, four ones. So if I look from the right side, okay, the right side is going to be what? Right side is going to be like 1 1 1 1 2 1 1 1. But if I look from the and I see from the left hand side, oh sorry, if I see from the left hand side, it's going to be what? 1 1 1 1 2 1 1 1. But if I see from the right hand side, it's going to be what? Same. So it's going to be what? 1 1 1 1 and 2 1 1 1. So it's going to be same from left hand side to right hand side. This is a valid palindrome. Okay. So palindrome is something that you can see from the right things from like so the left and right things are what simple. Now in this question I want to let you see two things here. Okay, converting all uppercase and removing and so question is saying that a phrase is a palindrome if after converting all uppercase character letters into lowercase letters and removing all alphanumeric characters, it reads the same forward and backward. Alphanumeric characters include letters and numbers. Okay, so you have been given a string like this. Now, what I want you to have a look at this is you have been given a string that is a man. Okay, and this is a comma here, and after comma there is a space here. So these are useless for us. Okay, so we are going to skip that. After that, we are going to see a. Then again, we have to skip. Space. So we are going to skip that as well. Then we have plan, then comma, and again a space. So we're going to skip again of that, then a, then space, then canal, and then we have colons, and then we have a space. So this is again useless for us, and then we have pana. So we're going to, so we have to like remove all these things because these are useless for us, and then we are going to, you know, transpose this into another string, and then we have to output the return is true or false or whatever the result is. Okay, so it's a, if it's a palindrome, then we have true. Then if it's not, then it's not a palindrome. It's called a false. So the return type is called boolean as well here. So see here in this example, a man, a planama, canal, planama, so something like that. But if you see from reverse, it's going to be the same one. Okay, so I'm not just going to read all these things. There should be something. So an empty string is also a palindrome. Okay, so because in an empty string, it's nothing, right? So it's going to be a palindrome as well. So this is a very good question to get you understand of how strings work. There are very two ways to do this. There are two good ways, I would say, to do this. Okay, so let me just show you something. Okay. Okay. All right. So let me just show you something. Okay. So let me just create the function. Okay. So public boolean. We forget the static is well. Every time we forget static. The static public, and then we have boolean, and is palindrome string. Yes. So we are going to return. Alright, and we have the valid palindrome question. Okay, so do this as well. Okay, and you know what can we do? What can we do? So let me just let's just call south directly and this palindrome, and then we can call a string. Maybe we can call it, you know, the same one. Okay, so a man is a palindrome and all those kind of things. You know, a man, a llama, all those things. So we're going to call that into this. All right. And if the string is, yes, there's the string is. So now how are we going to do this? Okay, so there are very two beautiful ways to do this. Okay, so it's a simple question. There are two ways to do this is by. Now I'm not going to jump into what the method we are going to apply. We know it's a 2-pointer question. Okay, so we are not going to jump into anything. It's a 2-pointer question. It's a 2-pointer question. So no doubt about it. It's a 2-pointer question, nothing else. There are very intuitive ideas to do this. Okay, so the one intuitive idea is to basically store all these characters. So like 2-pointer is what one method. Another method is you can store all these characters inside one array, and you can store all these characters from the right side, and then you can store all these characters from the left side, and you have to make a new function called character subtraction. Okay, so subtract all the characters from the right hand side and the left hand side, and if the character array is what empty, if there is no characters left inside the character array, the frequency array, then you have what the answer, because palindrome would cancel each other out. This would be one way. Another way is what 2-pointer question, but the character way is what going to be character frequency method is going to be what taking the space complexity of big O of n. So it's not a very good solution, right? We can do much better than that. So the solution is we can take char frequency method. So it's a character frequency method, then we have 2-pointer method, right? And then we can do what more method can we apply? What more we can do? We have a 2-pointer method, then we have character frequency method, then we can do a hash method as well. Okay, so you can store every character in that, and then we will check from left and right. So it's not a very good method. I'm just like blind running it myself. So we are not going to do the character frequency method. It's a bold and very bad idea. Okay. After we choose a method, okay, so for example, we choose this method. Okay, so I'm just going to write here. So for example, if we choose this. Okay, so for example, if we choose this, there is actually two more things I would like to remind you. Okay, very important, very important. Strings are immutable. Okay, so there is copy every time created, and it's a very important point. Okay, strings are immutable characters. There is a new copy created every time. Okay, so every time you see of like strings, if you create a new string, you cannot change the string. Okay, strings are not arrays, first of all. Every time you change something out of a string, Java creates a new string out of it inside the JVM. Okay, so if you create a new string from, maybe, you know what, if you create a new string from a string s is equal to new string, okay, string, and maybe you call it, ABC or something. So this is what a new string, and this string, okay, string s1. Okay, so this string is what created in heap. So this is created in heap, and it's not very good. That's why strings tells us that you know what, you can just create a new string directly. Se is equal to maybe what, ABC. You can create a new string like this. So it's what? So now it's behaving like a primitive object and not behaving like a heap object as well from here. Okay, that's not very good, right? That's not very good. And the IntelliJ will also tell you that new string is what redundant, and you can just replace the argument out of it. After we discuss this, I want to tell you that string always creates something that you cannot create. So, for example, if I create that, S1 is what, ABC, and now if I can just try to, maybe play redundant option here, that, S1 is equal to BCD. Then the redundant option here would say that, what, BCD is never assigned to, S1, because the new string was, ABC, and now you are suggesting it to BCD. So even if I try to print BCD here, if I try to print S1 here, then it will show me BCD, not S1 is equal to ABC. So that's the problem with strings. Getting my point? So the thing is that strings would always create new strings, and they would not be like immutable and changes. So now we have been left with two things. So I was telling this explanation to you guys is that you have to create a new string, because if you have to do that, and for creating a new string, the space complexity is what going to be? It's going to be what, big of 1, because it's not, because it's it's a primitive array if you're creating. But the problem is string takes things like an object. So the problem here is, if you take things in an object, then it's going to take a space of big of n. So the thing here is, you might be thinking is that why not we just trim the spaces, trim the characters, trim the numbers, and all those things. Alright, so as I was saying, that if you trim the spaces, the commas, and the numbers, and the columns, and all those things, a string is going to create a new string. Another way you can do this, you can just skip directly from the while loop. Okay, so if you counter a space, move ahead. Forget this. If you see a character here, you're only going to move ahead. So let me just show you the easy way. Okay, let me just show you the easy way, the good way. Doesn't matter if it's going to be what. So first of all, we are going to replace everything. Okay, so s dot and replace all. Where's the replace all function? Replace all. Replace all. All right. So we are going to replace all. String rejects and string replacement. Okay, so string rejects and string replacement. Okay, so we are going to create a regex, and regex is going to be what? A to, okay, not A to Z, huh, comma 1 to 0 to 9, hmm, and comma. Okay, so this is not the way. It's like replace all or replace. So if I do replace, what parameter is going to take? So if I take replace old character and new character, char sequence target and replace first. Okay, so it's like replace and replace all. Hmm. Okay. Hmm. All right. There's one more method then we can use to replace all method. Okay. So if it's like trim white spaces, then you can do this. There's already one more method. Hmm. If you can. Okay, so it's not replacing everything. So there are like two methods only for replacing. And if you do character 1 0 to 9, all right. What is that method actually? Let me just see once more. S dot replace all, S dot replace all white spaces and characters. What was that method? Let me just see. So there was a regis method. And Java. Yeah, this one. Yeah, this one. A to Z, Z to 0 and 0 to 9. Okay, so it's gonna replace everything. Yeah, this one what I was seeing. Okay. So S dot replace all. We have colon off and we have this. Yeah, A to Z and 0 to 9. Okay, so yeah, this works. Okay, so we have replaced everything. Now it's like simple thing. Okay, and then we have to like replace all. Then we have to like into lowercase as well, right? So into lowercase. We have did everything. Okay, so now it's very simple now. So int I is equal to 0 and j is not going to be well as is true. Then if then return false, and if not, then you know what, you can just return true. Or you can just do more simple way that if I is not equal to j, then you can you can return true. Every time you can return true, but now you have to like do you have to like traverse every time. Okay, so you can I plus plus and j minus j, and okay, and alright, so let's just see how it works. Sounds good. Now if I do something, a man, a plan, maybe a man, and I write something called court, then it should be like saying, what should being mad here. You cannot do that. Okay, so it's telling me, oh, a man who, right, give me two. If s dot caret I is equal to s dot caret j, oh, it's like breaking things. Okay, so it's like breaking things right now. Oh, so it's breaking things, right? So it's not good. Okay, so while I is less than j, then if s dot caret I is equal to s dot caret j, then I is equal to j, and if we traverse everything, then you know what? Else we can cross. Okay. And we can return true. And if we remove this here, then it should work, I guess. True. So it now works because if s dot caret I is equal to s dot caret j, then we have to like reverse every time, like I plus plus and j minus minus. But if not, then return false. And I can show you this from the debug pointers as well. So let's use debug. Okay, let's see. Alright, so you can see the string is working so perfectly. Now we move ahead, I to j20. Alright, so if s dot caret I is equal to s dot caret j, then you know what, just move ahead. And we move ahead now. Okay, so we know s dot I is equal to 0, I is equal to 1. Then you move ahead and just go ahead then. Okay, you know what? So let's just break out of this loop. And I 4, 15, 6, 7, 8, 9. Okay, so yeah, it works so well. Okay, let's just take a false example and then we can just copy paste the solution. So raise a car. Let's see if the solution works, and then we can be confident with ourselves. Raise a car and let's just push this code. Oh, I know it's false, but let's just see, because we should know that why it's false, no? So race a car is now being converted. Then you know what, just do. Now R is what matched with R, A is what matched with A, C is what matched with C. I is 2 now, so it's matched with, now it's E and A, so it's not going to be matched here. Now the third loop, that is E to J, I to J, and now 3 to C, it's not going to match here. So you know what, 3 to 4, it's returning false. Okay, it's simple. Alright, so let me just let this submit. Alright, there's one more method I would like you to say see this. Okay, so this is copy pasting solution. Yeah, this solution, we are not in this solution, we are not changing anything right now here. So if character is letter or digit, left, okay, and character dot letter right, only then you have to check that if character is letter left and character letter right, only then if character's lowercase left is not equal to character dot lowercase right, then return false. Else left is not equal to right, return false, and then you know what, just left and right. So it's a good way, okay, this is a more faster way, but to be honest doesn't matter. All right, so good solution, good intuition. Let's move ahead. All right, okay, so this is valid palindrome 2. Then the next question is valid anagram. Valid anagram. Reverse words and string. Reverse word string. Okay. Then the next question is remove all occurrences. Remove all occurrences of a substring. Remove all occurrences of a substring. Then we have string compression. Then we have a string compression. Okay. Then we have longest common prefix. Longest common prefix. Alright. Find duplicate characters. Okay. We have find duplicate characters in a string. Alright. Yeah, find duplicates, no duplicates. We have to find them. So, okay, I guess these 6 questions are good for now. 6. The 6 questions are good for now. Let's just solve them first, then we can move ahead. Okay. This is a cool solution. Let me tell you. Alright. Let me just see. Valid palindrome 2. Yeah. We know one thing, okay? S consists of only lowercase English letters. So we don't have to convert anything now. It's a clean string, okay? It's a very clean string. So we don't have to convert and everything and all those things that we were doing in here. It's a simple thing. Let me just copy paste this entire template and then we can see what the changes are in this question. The template is going to be same. It's going to be the same two pointer question. It's going to be the same two pointer question, but there is a very subtle change here. Duplicate code fragment. Extract method from duplicate code. So it's going to be the same thing here. Okay, what we can do in this point. Okay, so in this point, it is asking us that if there is, if you counter a character that is not, same here, then you know what, you can just remove it and you can see that if it's becoming a palindrome or not. Okay, so if there is a condition, if there's a like string, okay, so if there's a like string, let me just tell you. Okay, okay, so if there is a string called maybe a so it's like lowercase, right? So a b, so or what, raise, uh you can, simple examples like l a k b k a l. Okay, so this is what a palindrome, l a k b k a l, l a k b k a l. Okay, so if I add maybe, I add a z here. Okay, so z is what, z is not a character that is belonging in this particular palindrome. So what I can do is, if I can just, skip this, then I can see the rest of the characters, they are being part of the what, palindrome. So this question is basically treating us like the same. So what we can do is, if we counter something from the left and right, that what, it is not becoming same, it's not like the z, for example, if character at I is not equal to j, then what we can do here is, we can just skip the pointer. Then we can, then we can just skip the pointer, that what, I plus plus and j plus plus. So I is equal to plus 1 and j is equal to plus 1 at that point. So this question is basically treating us to do the same thing. It's basically only allowing us to just skip only one time. So while I is less than j, then what, I plus plus and j minus. Else if s dot caret I is not equal to s dot caret j, then what, then it is what telling us to do, it is only telling us to, what, just only skip one time. I is equal to I plus 1, that's it, and j is equal to j minus 1, that's it, and break, that's it. And else, what, else the condition is pretty simple, then you can, what, then you can just return false. Let's kind of see this. It's returning true, but it's not. Else if character of I is not equal to character of j, then I is equal to I plus plus, right? So I is equal to I plus 2 and j is equal to j minus 2. Then we just skip both these characters, right? And then we can just, and we not have to break. Don't break it, please. Don't break it, please. True. Got my point? So we have skipped the two characters, okay? We have skipped from the left hand side and the right hand side, okay? So this is what a simple one. Again, let me just, let's just run this here. Let's see. Okay. have an idea. I have an idea. What if we can use a count here, and we can just use count plus plus. Okay. Else return false. Okay. And return count is equal to 0 or 1. Then you can return true, else false. Or count is equal to 1. Simplified. Alright. ABC. It was giving me error in ABC. Let's just run on ABC here. It should give me false. Okay. Why is it giving me this particular problem? I is equal to I plus 2 and j is equal to j minus 2. Okay. And then we just count plus plus every time. Alright. All right. We were removing from the both the ends, so that was creating a problem. सिंपल है, हमें केवल ये चेक करना है कि पैरेंड्रोम में आई प्लस वन और जे माइनस वन एक बार हम स्किप कर सकते हैं, हम 2 बार स्किप कर रहे थे तो वो हमसे गड़बड़ हो रही थी, बट ओके, सो इट्स स्टिल अ गुड वन, इट्स एन इजी वन. Okay, so now the next question is called the valid anagram. Okay, reverse words when you move on occurrences in the string compression, longest common prefix and real. So we we still have a lot of questions. 6 questions now. So now we have been given statement if T written true, if T is an anagram of S and false otherwise. Okay, so okay, an anagram is if a nagram and T is equal to nagaram. Okay, then output is what equal to true, and then we have a rat, and then we have a car. Then what we are going to do is false. Okay, so this is a good question. Okay, and the s dot length and t dot length is what 5 into 2. Okay, and s and t consists of lowercase. Follow up: if the input contains only Unicode characters, how would you inform? Okay, okay, okay. Let me just tell you. This question is very good, but it's extremely simple. There is another question of the same category called a group anagram question, and that one is really good. So this is not one. This is not that question. Let me tell you, this is a very good question. Simple, intuitive, but pretty cool. All right, so let's do valid anagram. Let me just bring up my whiteboard. This question is really cool, and it's asking many companies as well. It's asking Expedia, Goldman Sachs, Amazon, Microsoft, Oracle, Morgan Stanley. If you're trying to target these companies, it's a good question for you. Let me just tell you what this question is. Okay, so it's a very good question. All right. All right. Let's go beyond that, and then we can go beyond that as well. Okay. This one, this one, this one, this one. Okay. See, this question is very simple, but it's very, very good. Okay. So, okay. S is equal to copy, then paste, and we are going to just paste it here. Okay. So, this question is what telling us to, you have to find the anagram of, you have to prove that is both these, what is these both are what anagrams of what anagrams are not. Okay. Now, anagrams are not difficult. What this basically means is that are the words appearing in S is equal to the words appearing in T. That's it. That's the only thing you have to understand about anagrams. Okay. So, into basically intuit yourself into understanding what anagrams is, let me just take these two things. Okay. Anagram A N A G R A M. Okay. So I have done what? I have just put it these values, okay, inside this. Okay. As you can see. And similarly, I'm going to take care of this as well. N A G A R A M. Now the thing is, if they are anagrams, these characters would cancel out each other until the strings are both empty. What I'm trying to say is, let's start from the below of it. There is M, we have cut it. Is there an M in an anagram in the T string? Yes, it is in, and we have cut it this. Move ahead. A here. We have three A's here. What we can do? Cut one ahead. Then we have R. Then cut R. G. Then we search for in the remaining string. Do we have a G here? Yes, we have a G here. Then we cut that string to G here. Then we have A. Then do we have a here? Yes, we have. Then we cut that here. Then we have N. Do we have an N here? Yes, we have. Then A. Do we have an A here? Yes, we have. So both the strings of now what have cancelled each other, and that's why it's a valid anagram. So yes, we can say that's a valid anagram, and we can say it's true. Similarly, in this case here, we have a rat and a car. So do we cut R here? Do we have a R here? Yes, we have. So we cut that here. Now we are left with AT and CA. Okay. So do we have a A here in the remaining string? Yes, we have. So we cut that here. Now we have T here. Do we have a T in this here? No, we do not. So T is not equal to what C. That is why it's not a valid anagram. It's equal to false. Now the thing is, how are you going to solve this? Okay. Now, two pointers is useless here. Why? Because if you're going to put two places here, you're not going to solve anything. There are two ways to solve this. There are two ways to solve this. Number one is called sorting. Sort those two strings. Sort the strings. And after sorting, you can just check that if string 1 is equal to string 2. Basically simple. Second thing, but sorting takes n log n. We can do better than that, and it's called character frequency. We take two frequency maps here. This is what F1, this is what F2. F2 contains string S, F2 contains F1 contains string S, F2 contains string T, and F1 will have all the characters frequency from every character out of it, and F2 will have similarly all the character frequency out of it. Then we can do is we can minus these two, And if C1 is equal to C2, that is sorry, F1 is equal to F2, that is equal to 0, then we can say what, that both these are anagrams, and then we can return true. The space complexity of this is going to be what, big O of n, and the time complexity of this is also going to be big O of n. So it is a much better solution than sorting. Can we use hash maps here? Yes, we can use hash maps here. Can we use hash set here? Yes, we can use hash set even. We can still use hash set even. Why? Because convert all these characters of anagram into characters, string into characters, put these into the hash set, map and match every character of t into that. And if you can find every character of this inside that, then you know what, we have found something. But the point of here is hash set is useless, because if there is another character extra in t, it's not going to match, because hash set only stores individual unique values, not duplicate. So hash map is a good solution, not a hash set. Why? If you put every character of s inside a hash map with the characters and their frequency, and you traverse from t, okay, so if s is not equal to t, the length is not equal to t, then we return false. But if they're equal, put all these inside the hash map, and if yes, map every character of t inside it. If you found that into the hash map, remove that character. And if you if you matched everything out of it, if the character frequency key is equal to 0, then you know what, remove it from the hash map, and you have to just check that if map size is equal to 0 or not. So there are three ways to do this: either by sorting, either by frequency, and either by hash map. We are going to do all three methods today. Okay, so it's a good solution. That's why I was saying it's a good solution. Okay, because we can do this question with three ways. All right. Valid anagram. Okay, it's a good question. We are going to solve this in all three ways. So that's why we can understand ourselves that what is true or not. Return true. Okay. And we have to just check that if s is equal to 3. So just check south and check, only just paste this here. So just remove these things, useless here, add home. Okay, so we'll just remove this here. Okay, so we just check both these two terminologies here. String s is anagram and string 2 is what? Nagaram. Remove redundant println calls. Okay. Oh, sorry. Okay, it was right. I was making a mistake. Just give me two minutes. Give me 2 minutes. Okay, so it's what is anagram. Is anagram. All right, and we have to use the static function, because you cannot call a static non-static variable inside a static function. So it's simple Java. Yeah, always remember that you cannot call a non-static reference into a static reference. So that's why it would create a lot of problems. Now coming back to the solution. Okay, let's write some code. Okay, let's write some code. We are going to do this question in three ways. Okay, so first of all, let's just mark everything. Okay, if there is equal to less in m is equal to n. Okay, now a basic check that if n is not equal to m, then you know what, it's never going to be an anagram, right? So every time you just see this, then return false. And why is it giving me answer? If statement can be simplified. If else. No. Okay, now we're going to do this in three ways. Okay, number one is character frequency check. Number two is hash map, and number three is sorting. Okay, we are going to do every solution. Okay, so let's do the character frequency check first, and then we can move ahead into much simpler solutions. Okay, you know what, let's just do sorting first. Sorting is more time complexity based, so let's do sorting first. Okay, so it's simple. Let's do something. Arrays dot sort, or you can do yeah, you know what, let's do this. Okay, so let's do character of character of S1 is equal to S dot 2 character array, and T1 is equal to 2 dot character array. And you know what? Sort both these two arrays, and uh, for int I is equal to 0, yes, I less than m. If we have to check now, if S dot I is not equal, S dot I not S1 dot I is not equal to what? T1 dot I, then you know what? Return false. Immediately return false. And that's it. Then you know what? You can return true. If not, then return true. So if it's valid anagram and nagagram, then it's going to return true for us. Yes, working. And if you want to see that if it's working or not, just like skipping everything, then put another A here, and it's returning false, but it's working. Okay, so this is what a nagagram solution would be. But why is it not a good solution? Okay, why is it not a good solution? Let's run this. Okay, let's just see why is it not a good solution. Okay, and let me just submit it. So it's a bad solution because it's giving me 13.3% memory. Okay, and let me just see if what it's giving me on the space complexity, right? So the space complexity is n log n, and when this time is n log n and space is big of n. Why? Because sorting in place does not require additional space beyond the input arrays, and therefore no significant data structures used. Converting strings into character arrays use the big of n time. That's why, right? So it's not a very good solution, but it's still a solution. Okay, and right? Okay. We are going to be using these two things inside character frequency check as well. So we are just going to copy paste this here, and we are going to just for now we are going to like comment it all out, and like we are going to commit everything in process. Okay, getting my point? Now back to the next thing. More solutions. Okay, more solutions. Let's go for more solutions. Now we have the hash map solution. Okay, hash map is a good solution. So the hash map solution includes creating a hash map. Okay, so let's create a hash map and character integer map. For int I is equal to n, then you know what? You can just use character c is equal to character type, and you know what? Map dot put everything. The map c dot get default and c dot type. Okay, so right. what we did here is, if my map contains a key of t dot caret I, then I have to minus the frequency of it, and if I get the frequency of 0, then I have to remove it from the map. Getting my point? So it's checking every time into inside the map, and this is the solution is. Now let's run this. Okay, let's run this. It's going to take big O of n time, not big O of uh, let's run this. Let's submit this. It's going to work, and it should work. Oh, it's way worse on time complexity. Interesting. It should not do that. But let's see what the time complexity this is, because sometimes lead code compilation time is absolutely bullshit. Time complexity of the given code is big of n, where n is the length of the input strings in SNT. This is because code iterates through each of the character of S1 to build the frequency map, and then iterates through each character of T once to update and check the map. Both loops are linear in size complexity, and since the strings are of equal length, the overall complexity remains O of n. The space complexity is also O of n. The first case is due to the hash map used to store the character count, which potentially hold in every character of an input system is unique. In the worst case, the number of unique characters is the space complexity of the equal. It's a very good solution. Okay, I don't know why lead code is behaving like that. Let me just turn this into true, and let me just put this into sleep. All right, so another great question, another great solution we have discussed. Now coming to the third one. Okay, this is a very good solution. Now we have two frequency arrays, a array of S1 and array of S2. We have did this. Now what we are going to do now, okay, what we are going to do here is, we are going to count the frequencies of S and Y. Okay, you might not getting understanding what I mean is, okay, let me just try to tell you something. New int, new char, and n. Okay, and character s2 is equal to n. Let me just try to build something, and you can then understand all of it. So s1 of I is equal to frequency of we do not need n and m here. It's just a 26 marker array. I forget that. I forget a lot of things. And we don't need to traverse to I. We just need to traverse to 26 here. Now, character or you know what? S1 of, and it's going to be int int of s dot char at I minus a plus plus, and similarly s2 is equal to t dot char at I s plus plus. Okay, and let me just run another for loop, because now we are going to check every time s1 dot length 1 1. If s1 s1 dot I minus, if let's debug this. Let's see. It's a good solution. I don't believe it's a good solution. It's a great solution. See, there's an empty array of new characters. There's an empty array of new characters. Now we are going to put anagram in here. Okay. So S1 is equal to int of S dot character minus A. So first character is what A. A minus A is what? 0. The first character is going to be what? 0. Okay. Got my point? Then S dot character minus A. T. Now T is what? Nagaram. N. N is what? A, B, C, D, E, F, G, H, I, J, K, L, M, N, M, N. So 12, 13, 14. 14 minus A. It's going to be again, it's going to 13. Okay, so 13 going to be answer. So we are not seeing S2 here because we are seeing it at 13, at position number 13. Where is it? Where is it? Yeah, value number 13. Value number 13. 13. Value 12, 14, 13. Yeah, C. Value 13 here. So it's putting value here. Okay. So yeah, we move ahead. Then we fix all the values. Okay, so we fix all the values. I4, 5, 6, 7. Yeah. It fixed. Finished all. Now the big question: if 1 to traversing, if S1 dot I is not equal to S2 dot I, then you know what? Just return false. So it's going to match everything, right? Let's take a simple example. It's not okay, but it's going to create every map from it, right? So yeah, that's the good solution that we can think of. So that's it. Okay, so it's going to work again. It's again going to take a big of n time, but it's a much faster solution because it's only taking it's simpler for loop. Alright, let me just paste the solution once and then you can see for yourself. Alright, this is a good solution. Alright, let's just copy the whole solution here once. Alright. Okay, good solution, good question. Okay, reverse words in a string. Given an input string is, reverse the order of the words. A word is defined as a sequence of non-space characters. The words in S will be separated by at least one space. Return a string of the words in reverse order, concatenated by a space. Note that S may contain leading or trailing spaces or multiple spaces between the words. The returned string should only have a single space or trailing between the, do not include any extra spaces. Okay, so फ्रंट लाइन के हमें हटाने हैं सारे स्पेसेस और बाकी बैक साइड के रहने देने हैं जो बीच बीच के हैं। ओके, you need to reduce the multiple spaces between two words to a single space in the reverse string. Okay, okay, so इसमें कितने स्पेस आ रहे हैं? 1 2 3। ओके, सो 3 में से हमें एक हटाना है। ओके, it's a good question. And this at least contains one word in it. If the string type is mutable in your language, can you solve it in place? Will we go for an extra space? Okay, so it's not mutable in our language, so we don't have to care about that. Okay, commit anyway. Alright, so I'm sorry. Okay, reverse version string. Okay, so okay, there's a function in Java in which you can trail white spaces from the front. Let me just trail white spaces from front. Java. What was that? Yeah, strip leading. Yeah. Text dot strip leading. Okay, it's a good one. If you have not used it, it's a good one. Okay, okay. So we are going to use first strip leading. So let me just go back here and then we can. Okay, let's do. Okay, the question is reverse word in reverse words. Reverse words or reverse words? Public string. Because strings are immutable in our language. Let's see if other languages also have immutability. Def reverse words, we have to return a string here as well. What about C++? Okay, so C++ is also giving immutable. And what about JavaScript? JavaScript can immutate. Yeah, JavaScript can immutate. Okay, JavaScript is mutable. Alright, so let's see. Okay. Static public reverse words. And we have South reverse words. and hello world. Okay, first of all we are going to do what a strip leading. So s is equal to s dot trim all, strip leading strip leading and strip trailing. The trail white spaces can be the strip leading. Okay, so strip leading, so strip hello world, text dot replace first, trimmed जैसे text dot replace first. Okay, so it's like this normal trim. Okay, trim. All right, so we have now trimmed the function and string public string, static public string. Return null. If you have not known till now, you now know that strings are also null. Okay, so once we have trimmed everything, how are you going to return it? Let's return s only. Let's see. So it's giving me hello world. Okay, so it's not trimming everything around it. The question is the edge case that is I am most worried of. For example, if there is hello world here, okay, forget everything about it. The thing is 1 2 3, how am I going to trim the between white spaces here into that? Okay, uh, we are going to use a swap function first. We are going to use a swap function. So int I is equal to 0, int j is equal to 0, while I is less than j, then char temp at. Okay, while int I is equal to 0 and s dot char at I does not equal to is equal to empty. Yep. Yeah. Then char temp is equal to s dot char at I, s dot char at I is equal to s dot char at j. Variable expected. Variable expected. Oh, char left. Okay, then we have char right. Okay, so I think things are now pretty much clear. So char temp is equal to left, left is equal to right, right is equal to temp, and then we have I plus plus, and we have j minus minus. Okay, all right, all right. uh, Character of temp is equal to left, left is equal to right, and s dot caret I, s dot caret j. Okay, hmm. We were not changing s at all. That was the problem, dude. Then we have to use something called chars, and right, and yeah, this was the faulty one. Let's remove this. Yeah, that's this is all the faulty things here. All right. So char temp, char okay, let's see. Oh, sorry. Return new string chars. All right. We'll do a hello. And the world hello world contains uppercase, lowercase, and spaces. Return a list to concatenate else case. Dot replace all dot to lowercase. All right, good. Oh, 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 I'm sorry. All right. The sky is blue. Blue is the sky. Blue is sky. The oh, we have to. Oh shit. Oh shit. Blue is sky. The yeah, yeah, yeah. Okay, 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 okay. Output elab is the sky down. Okay, 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 okay. So how am I gonna do it? How am I gonna do it? How am I gonna do it? Tell me. Tell me. It's simple. It's simple. We just have to take a string character. String. Okay. It's everything going to do. And this also. And we will do this one. And this also. First of all. So string str is equal to s dot split. Okay. This is very important right now. Very very important. This is going to be the factor. Okay. And this string is going to be now replacing everything. Okay. So okay. All right. So string temp is equal to str on right and str on right is equal to. Now this should work. Index 10 out of bounds for index 10 out of bounds for length 2. Oh, sorry. How should I given this? Return new string str. Arrays dot toString. World hello. Ah, string. Reverse equal to. Yep. Yes, 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 yes. Return reverse. Oh, oh, okay. return reverse dot trim. All right. All right. Okay. So there were some minor mistakes. Don't judge me. Everyone feels and falls in the same category, right? Okay. So yeah, it's a good solution. Okay, we trimmed this and then we replaced all the spaces with what this. Actually, we can replace this also. Let me just try to replace this. All right. Uh, let's see if it would run now. Oh, okay. So we need this. Otherwise, it's going to be right. You know what? Okay. So I was thinking that if it's gonna add some space here in this, but okay. 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 So we're just gonna convert that to this. Okay. What's the good solution here? So the good solution here is that you have to just just replace and split all these. Then use a string builder. String builder is not thread safe, so we do not usually use this. Then from the last, you know what, just append words out of it. And if I is not equal to 0, then sb is equal to this. Wow, that's a good solution as well, right? We don't need to reverse everything or not. Just put inside the string words and then just make string from behind of it. Good solution. Good solution. Technically very fast, but we were using string builder that which just replace all this inside. But okay, I get it. I was like reversing everything when it is not even necessary. Wow. String reverse is let's take a empty string, and for an empty string we just reverse it from string dot length, and what the reverse is going to be. The reverse is going to be the string of I, and it's going to add a space in between. Okay, so yeah, and return reverse dot. Okay, so trim all the edges and all those that you are getting inside here. So okay, so it's a good one. Okay, it's a good one. I think it's an easy one as well. Okay, it's a medium one, but it's a good one. Okay, it's a good one. It's a good solution. Beautiful. Okay, let's move on to the new solution that's called remove all occurrences of a substring. Okay, so this question is given two strings s and part. Perform the following operation on s until all occurrences of the substring part are removed. Find the leftmost occurrence of a substring part and remove it from s. Then return s after removing all occurrences of part. Okay. Is it a Rabin-Karp based algorithm or something? String stack formulation. Okay, we have to remove every aspect of it, and then we have to remove the leftover array out of it. Okay. So if I see it's like xy, then you know what? Just remove xy out of it. Okay. All right. D, A, B, C, ABC. Removing ABC starting from index T, so DA is equal to DAB. Now S has no occurrences of ABC. Input X S is equal to XY, part SY, remove. Note that a new occurrence pattern can appear if we remove an old one. For example, S is equal to ADABC and pattern is equal to ABC. You can maintain a stack of characters, and if the last character of the pattern size in the stack match the pattern, remove them. And if the last character of the pattern size, okay, let's see. केएमपी रिवाइज करनी पड़ेगी। We have a KMP algorithm here, तो अच्छा है, हम सीखेंगे KMP algorithm, लेकिन तो फिर टाइम है। All right, let's move ahead. Let's see more questions. It's a good question. I enjoyed it, and you should too. All right, so let's move. Okay. Okay. All right. Okay, so this question is called a string compression. Given an area where area compression consecutive repeating characters. If the group length is 1, append the character to S. Otherwise, append the character for other the compression should not be transformed. Should be stored as the input before is this received on 6 before 6 bit string operation it 2 bit of what so for example if I give maybe 0 array मांग रहे हैं चिप्स मांग रहे हैं all right okay but the thing is how am I test this Okay. Uh, okay. Okay. So there's one thing I can think of. I'm sorry, I was on a break. I'm sorry. But there's one thing that I was thinking. Okay. So here with me, what kind of a data structure can help me traverse all this in just one pass? Okay. And without storing anything except from the return type, not gonna store anything. I think the finest data structure that we can think of is maybe a maybe single pass. And but how am I gonna? The thing is, like, see, look, the thing is, see, bear with me, okay? See, the thing is, how am I gonna count each element once in every single pass? I think that's a two-pointer question. Now, see, how am I gonna use two pointers here? Okay, so bear with me. I will put I and j both on zeroth position. Okay, I will put both I and j on the zeroth position. I will traverse from the single for loop, that is for loop. Okay, for loop from I to n. Okay, now what am I gonna do is, so I is going to be at 0 and j will be the one that is a fast pointer. Okay, now while I is equal to at 0, and if char dot s dot caret I is equal to s dot caret j, okay, then I'm going to what, continue. But if s dot caret I is not equal to s dot caret j, I mean that if my I is now equal to, see, if my char at I, okay, so my I pointer is at here, okay, suppose my I pointer is at A and my j pointer is at now B. Okay, so A is not equal to B. That's my that means my code has broke now at this position. That means I have traversed A here. So I'm gonna count each occurrence of a character here from count is equal to 0, and I'm gonna push the count and the character, that is the s dot char at I, and count both in these both in a data structure. Now, what kind of a data structure can help me store both count and this in one go? That is, I believe, would be an array list. Getting my point? So an array list can help me both push uh, character and the count of it. All right, array list of characters can do that for me. And once I'm done with that, then I'm gonna create a new character list and I'm gonna push back all the array list characters inside that. This is what I have been thinking of, and this is what I'm going to do for the string compression. Okay, so there is one more thing that we have to take care of, and that is we have to take care of each time when we are counting characters. Okay, so this is a very important thing. All right. Let's string compression. All right. It's a good question. It's a very good question. And then we'll do this question. This question is very simple. We'll finish this in very instantly. We'll pick this one element, and then we are gonna what, then we are gonna match with this, and if it is not equal to the rest of it, then we are gonna minus out of it, and then we're gonna check again, and then we're gonna minus out of it, and we'll check again, because the string length is 200, so it doesn't matter. Okay, so let's check. And then we have the duplicate characters. This question is also very simple, that if you given a string case, then you have to remove the duplicate letter so that every letter appear only once, and you must make sure that the result is always in the smallest lexicographical among all possible characters. Okay, so we will do this as well, and then we'll do this as well, okay, in the lexicographical order. Okay, smallest subsequence of distinct characters. So this is also good question. Okay, so we'll do this as well. Good questions. Okay, string is very beautiful, but it's little bit of different in comparison to what a normal array seems to be. Okay, there is a problem with LeetCode here, that it is asking me need to return the characters out of it. Okay, so what LeetCode does is basically it will strip all the characters from its recommended answer, and then it will return itself in it. But we don't have to like do it anything here. So what we are going to do is we are going to change the return type to character of array, and we are going to do it like we put static. Okay, and the return type is going to be what, character of arrays, and then we'll put null here. All right. All right. So okay. So let me just push everything out of it, and then and then we're gonna do maybe south and compress. Okay, and then we're going to put everything in here. So right this. Okay, okay, and then we're going to okay, push everything in here, and then okay, so array initialization move around. Okay, so arrays dot to string carry, and we are just going to push everything out here. All right, array dot to compress and return null static public function. Okay, what is going to add new char, new char. All right, okay. Hmm. Okay, okay. So see, the thing is, you have to like put the count and the count and the array list of it every time. How am I gonna do it? Okay, so this is the big thing, right? How am I gonna do it? Okay, so which data structure is more flexible in adding all the items regardless of the type? Okay, so let's use Google. Okay, I don't know because I'm gonna search it. Okay, so which data structure in Java can store any type of can store both characters and integers. Okay, both characters and integers. Okay, so let's see. So we can create an object array. It's saying that you can use, you can use an object array. There's no way to multiple show. Okay, so what we can do is, okay, so okay, so let me just do one thing. Okay, how to push, how to convert um, int to char in Java. Okay, let's see. Because I was thinking one thing, direct casting, treating as Unicode, char of this and new character. No. Output 5. Okay, so character is equal to digit plus 0. Okay, so we're going to do this. Okay, we are going to do this. So let me just use something. Okay, we are going to use an array list here. We are going to use an array list here, and we are going to make it of character. And this is going to be what our rest and new array list. Okay, after we did this, so yeah, and we are going to equal to cache of length. Now, bear with me. We are going to count every occurrence of it. Okay, so we are going to take 2 pointers here. Okay, we are going to take 2 pointers here. 2 pointers, one fast, one uh, one slow. Okay, So what we're going to do is we are going to take int I is equal to 0, and we are going to use it until the j length. Okay, so what we're going to do is while I is less than n. Okay, so not I is equal to, forget it. For int j is less than okay to what, nn. Now this is important right now. Okay, this is very important right now. From j is equal to g is equal to, okay, now very important right now, so bear with me. Okay, if character of char of I, oh sorry, j is equal to character chars of j, then what we are going to do is we are going to count plus plus. Okay, we do not make a count function, we should make a count function. Int count is equal to 0, and we should take it inside the for loop because you have reset it. Okay, so count is going to be what? Count is going to be plus plus every time it equals to, basically plus plus. And what we are going to do is we are going to res.add characters of j one time only, and we are not going to add it one time. Count plus plus res.character j. How am I going to do it? Because it's equal to 1 is equal to j, then count plus plus. Okay, how am I going to do it? Okay. And else if characters of I is not equal to characters of j, then what? I is equal to j, then what? I is equal to j, right? And then count is equal to 1. Then what? Count is equal to 1. And we should not do it like else if case, because it's like understood case, right? So just do I is equal to j and just count plus plus. Now come out of the for loop. Okay, come out of the for loop. Alright, come out of the for loop. Now what are we going to do in for loop now? What are we going to do outside the for loop? Alright, what are we going to do outside the for loop? That if count is equal to that if count is equal to 1 and count rest is equal to what? Chars of I, count is equal to plus plus, but now elements are added in break. Count is equal to 1. So else what? Else rest is equal to characters of add of j and rest.add and the similar thing here. Character count of 0. and this here. Okay. If count is equal to 1, then rest dot add characters of I. Okay, and then you have to just return rest. नहीं rest नहीं करना है return how to convert array is char array. Okay. Okay, let's see now. Let's see what it gives us. Okay, it gives us A1, B1, BB1 and C. Okay, so it's definitely not what we are expecting right now, right? Okay, so int count is equal to what, 1, and if chars of I is equal to chars of j, then we will not do the count plus plus, so it's now count 2, else rest dot char count is equal to 1, else if. So it should not be like else if chars of I is not equal to chars of I count plus plus, and else I minus minus, and this will be plotted outside. Yeah, this should also be plotted outside, and yeah, okay, and because already लूप में जब आ जाएगा तो प्लस हो जाएगा, जब J1 पे जाएगा. Okay, so we are on chars I equal to chars of j, else I is equal to j, rest dot chars of I, and count is equal to 1, rest dot A2, B1, BB2, C1, C2, C2. Okay, I got it. Okay, so it's working, but ये expand कर रहा है जो करने की बजाय. A2, B1, B2, C1, C2, C2. It's not compressing anything. Okay, so it's adding rest dot I every time. Okay, so it traversed A, then it's gonna add B. So char dot is equal to j, then we're going to add this, and then you'll just what? I think we're gonna break everything. Okay. No, it's not working. So I should not add this. Let's see. A2, 1, B2, B1, C2, 1, 2. Okay. let's see something. And that if j is equal to n, j is equal to n, or characters of j is not equal to I plus 1, then rest dot chars at I chars of j is not equal to, and now add rest dot chars of I. Alright, and then you add, then int count is equal to what? J minus I. Alright, and if count is greater than 1, then for character C of integer dot string count dot count array, the rest dot add C. I is equal to 0. Now let's see. A2, B2, C3. See, it works. What if it's of a single array, right? This is an edge case, so it only adds this. So it works, okay? So this is a very good question. Very good question. What are we doing here right now? It's using two pointers. We call it I and j. Now, if j is moving from 0 to n, because it's counting from the last element as well. So if j is equal to what? N. Now, what is n here? That is the characters dot length. Okay. So if j is equal to what? N, or what is the condition to break things here? That if characters of I, characters of j, now if for example characters of j, for example a here is not equal to what, for example character of j is what b here, and it is not equal to what, it's not equal to a here, then what is it going to do? It's going to add now the rest of chars at I. It's not going to now going to add a, and it's now going to add count of j minus I. So what j is now here equal to? J is equal to 2 minus 0 is equal to what? 2. So count is equal to 2. Now if count is greater than 1, then what is going to add? Like for character C, integer dot to string count. So count is what? This count 2. Now char array. So now rest is going to add C. So first added chars dot I, and then it's going to add C here. Getting my point? And then we're going to reset the pointers to I is equal to j. Let's kind of, in order to understand things well, I already told you in like simulation, but it's still okay. Let's add. Let's see in this. Okay. So AA, BB, CCC, and N0, F0. Okay. So this is what I0, J0. Okay. So it matches now. So J is equal to 1. Yeah, it's equal to 1. No, it's not equal to the correct. The station is still false now. Now it's again matching. Now it's still false now. I is equal to 2. Now when J is equal to a 2, 0, it's not equal to what? This condition is now broken. Now it's going to add rest dot chars I. So now rest is going to add a here. So rest is going to add a here, as you can see here. And if I can just show you that, then rest is adding a here. Okay, value a. And once it adds that, now j is adding 2 here. Now if count is greater than 1, then what's going to add? It's going to add count is equal to 2, and rest is going to add, you know what? Rest is going to add 2 here. So it's going to be what? Size of 2. Okay. So I is equal to j. Now I is equal to j. So I is equal to 2 and j is equal to 2. Okay. So it's a good question. Okay. To test yourself. Okay. Let's just all right. rest dot stream. Okay, is there a problem here? Dot to char array. Now char array cannot be converted to int. Dot to char array. Wait, how am I gonna supposed to give the answer back? इसे रिटर्न कैसे करना है फिर? ओके, डॉट टू कैर एरे क्या है? इनकम्पेटिबल टाइप्स, कैर एरे इज नॉट इक्वल टू इंट, बिकॉज जब मैं इंट करना था तो तुम ले नहीं रहे थे इसे. ओके, तो मैं रेस्ट डॉट साइज लिख दूं फिर. रेस्ट डॉट साइज. Yeah, I guess we have to copy back items here. So this is the only thing we were missing. So let's just copy back items here. Okay, so suppose I do this. Okay, I copy back these items and then I run chars dot k equal to rest dot size. Okay, stupid. Where's my solution? Very bad, but don't care. 2 pointers, one fast, one slow. This is going to be the case here. Okay, it's a good case. Don't judge me at all. Okay, this is a very good answer. All right, what people have written here? Now index is equal to 0, I is equal to 0, while I is less than unit length, char character I is equal to 0. Now while I is less than char dot length and char dot I is equal to current, then I will press count. Char index plus plus is equal to current. Now if count is equal to 1, then string count is equal to string dot value of count. And for the char index plus plus is equal to return the index. So it's a good solution as well. First, make the following observations. Okay, consider a group T of consecutive repeating characters. The length of compressed T is less than or equal to the length of T. For example, D transforms into D C C C. अब इसको frequency वाले को भी यूज कर सकते हैं. characters are in white cells. Process characters that we may overwrite in the future are in blue cells. Characters that belong to the answer will not change in green cells while processing a variable. First, when processing, we ignore them as going to declare a variable. Okay. Show me the code. Okay, while I is less than cache data, then group length is equal to 1. While I plus group length, okay, for example, I is 0 here, so 0 plus group length, so 0 plus 1. So 1 is less than characters dot length, so characters dot length is minus 15. So 1 is less than 15, and characters of 1 is equal to characters of 0. Okay, then group length plus plus. Now characters of rest plus plus is equal to rest dot I, and group length is greater than 1. Okay, then I plus. Wow. Good question, but still आर्ट्स is very better. हमारा इंट्यूटिव है, समझ में आता है लोगों को. All right. Hmm. Good one. Hmm. This one is also good solution. All right. Let's move on to new solution. New question now. Now it's called the longest common prefix. It's a good question. It's a simple question, but it's a good question. Okay. Simple and good. We know the longest common prefix is something that comes in every other string length. Okay. So this question can be solved in a simple manner. Is that you take the first element, the first zeroth part of this string as your prefix. Okay, your string prefix is going to be this one, and you will compare each time with the rest of the strings from string 1 to string dot length up to how many times it's going to pass, and you will match each time this one happens. Now if your prefix, that is this one, does not match any of those strings, then what are you going to do? Then your new prefix string is going to be this, the whole prefix string minus the last of the prefix string. Okay, and you're going to do it every time, and you're going to match it again. And if you found your prefix, that is, if you found something that you're going to add everything inside it, then you've got your answer, then you're going to return this final result. And if not, then your string is going to be just what, empty. All right, so this is a good question. It's a very simple question, and yeah, we're going to do it. You can do it with your two for loops as well, the brute force approach, but you know, it is telling us in phase that it's 200 and 200. You can use that, but if you know this solution, then why you don't waste your time? All right. All right, it's a good question. Okay. Longest common prefix. Good question. Alright, ladies and gentlemen, now we're gonna solve this. So return prefix. Now you're gonna asking, Akshay, what is the prefix here? Okay, so now this is complete and just empty string. But if you not but if you're asking what is prefix, then I'm gonna tell you what prefix is. So we're gonna write a prefix. So prefix is going to be strings of zero. Now this is what I'm telling you from the first time. Suppose flower is the prefix that you're looking for. Now flower does not match to it, does not match to it. So anytime that you do not find that this is not equal to this, what you're going to do? You're going to simply reduce this flower prefix from 0 to n minus 1 minus 2, and you're going to reduce it each time. That is, for the first prefix, the original prefix is this. The second prefix is going to be FLOWE. You will remove R from it. Then you will remove in the next case E, then W, then O. And then you're going to match like FL is equal to what? You know, the FL is matching this and this and this. Then you'll find your prefix is what? FL. Okay, so we're going to do this every time. Okay, now your prefix is string of zeros. Then how are you going to find it? Okay, how are you going to find it? Then you're going to check. Then because your string prefix is from strings of 0, right? So string of 1 you have to check, and I is less than strings of length and I plus plus. Now if prefix does is equal, now if prefix is equal to, no, if prefix okay, let me think. Okay, so if prefix, okay, so I have to check prefix anytime, every time for this. So I have to check the occurrence of prefix on this, on every time, right? I have to check how prefix is equaling. What is this string solution of string s is equal to strings of I. Now if prefix is equal to s, does not equal to s, then prefix is equal to prefix dot substring prefix dot length minus 1, and you have to return prefix is not equal, so objects do not equal prefix is. Now let's see. Flow, it's giving me flow. Why? Oh, strings dot length minus 1 minus 1 minus 1. Flowy, so it's just removing 1 only. Okay, so why is it happening? Okay, so I from 1 to strings of length and strings of s is equal to strings of I. Is equal to strings of length. Then prefix of something is called prefix of you have to return it every time, but if not, then return prefix, and if dot equals this. Okay, so prefix is equal to prefix dot substring prefix dot length 0 to prefix dot length and this minus 1 prefix dot length 0 to prefix dot length minus 1. Okay, so prefix is equal to prefix dot substring prefix dot length minus 1. All right, so all right, now it's giving me flow. Why? Because flower and flow, but it's not checking flight. And why is it not checking flight? Now if object dot equals prefix, so while So should I use a while loop? Okay, so while, let's try to use a while loop. Okay, so while true, if, okay, not while loop, while I is less than this and this. Okay. All right, then I plus plus. Okay, they have not written I plus plus. All right. Karina, no, they all we couldn't stand me. Hmm. I less than strings dot length I plus plus and prefix is equal to prefix dot length minus one. So into like minus every time. Okay. So okay, I think I got the crux. For int j is equal to 0, and then we are going to see every time. Now I is going to be what, 0, and j is going to be what, 1. Now this is going to check every time, and we are going to take prefix of 0 here. Okay, so prefix is going to be what, global. For j is equal to 1, which is what, prefix of I and strings of j here, and if not, then prefix is equal to prefix of length minus 1. Exception found. 12. Okay, so 12 was a prefix of if object dot equals return prefix of j, then you know what, you can just move ahead into 0 is equal to string dot length into, so it's going to be int of 1 and int of 2. But if the size of it is 2, then what are you going to do? So you're going to take one is a, or you can take I plus 1. So you may take care it as 0. Alright, alright. So it's not working. It's not working at all. Okay. So strings of maybe I, then yeah, and then int I is equal to 1. Okay. Alright. Or we can do that if str's I does not starts with prefix, then you can, you know what, then you can chop it down, and then you can just return prefix, but prefix is already getting returned. So it's like bullshit versus bullshit is equal to what, bullshit. So it doesn't care for us. Okay, so yeah. Hold your eye, we are local, don't feel shy, we are local. वाइल जब तक करना है, जब तक स्ट्रिंग मैच ना कर दे इसे, तब तक करते रहो भैया। ओके, तब तक मैच करना है तो ये होना जाएगा, तब नहीं होगा तब तो स्ट्रिंग की लेंथ जो है माइनस करते रहो। एंड इफ यस अगर मैंने ये ना करा तो लूप में भागेगा, देखते हैं। इट्स स्टिल गोना रिटर्न, तो मैं ये क्यों बकवास केस लगा रहा हूँ। ओके ऑलराइट, we can also do this by recursion as well, if you know. We can also do this by recursion. So by recursion we can do we don't have to do this, we don't have to run all these loops and all this, but we can do directly through recursion. Okay, so what we can do here is that alright, so yeah, oh this is a good solution as well. 0 से लेंथ तक चलेगा, then we have 1 to k minus 1, and if I is greater than s square of n, it does not equal to s square, okay, then return the string from 0 से लेकर I. Good one. I think ये column scanning का work कर रहा है. Okay, yeah, this is a horizontal scanning, right? question is remove duplicate letters, and then we have to return all the characters. Make sure the result is in the smallest lexicographical order among all possible results. Okay. So we have, okay, so see, we have reduced, see here, let me, okay, smallest lexicographical order, doing the stack greedy. Oh my god, stack. Simple question. Adjacent duplicates, and this was one question. Rotate string. String rotation. A goal A, output true, expected false. अरे यार, if s dot length is not equal to goal dot length, then return false. Ah, so stupid. So stupid. Yeah. All right. Okay. So good. Okay. Good question. If you don't know how are you gonna solve it, then it's going to be very difficult. For example, I was starting to think in my first hit was if I can use K or something here, but then I understood that it would be very stupid. Okay, so if you can see high acceptance rate, you must know that there must be some kind of string matching or something. All right, so it's a good question. Hmm, I think गलत बात है. चलो ये अच्छा क्वेश्चन. All right. You're given a string s and an integer array indices of the same length. Okay, the string s will be shuffled such that the character at ith position moves to indices I. In the shuffled string, return the shuffled string. a formula. Count and say 1 is equal to 1. Count say is equal to length. Encoding and length encoding is a string compression method that works by replacing consecutive identical characters repeated one more time with the concatenation of the character and the number making. For example, it is 4, then it is what? 1, 2, 3, 4. 2, 3, 4. What? What? Count of 1 is 1. RLE of 1 is 1, 1. RLE of 1, 1. RLE of 3. RLE of 1, 1. Is it 2, 1? RLE. भाई क्या गंदा क्वेश्चन है यार ये. Could you solve it iteratively? This is the base case. तो मुझे 1 से लेके 4 तक के सारे डालने हैं and then I have to like merge everything together, right? So for example, if I have 1, 2, 3, 4, okay. So 1, 2, 3, 4 going to be what? So 1 is going to be 1, 2 is going to be 1, 1, RLE of 1, so it's going to be what? 1, 1, alright. Then 3 is going to be 2, 1, and 4 is going to be I'll see it. Okay. Create a helper function that maps the integer to pairs, for example. Create a helper function. Okay, forget this. Let's move to this. This is a good question. Okay, so how are we going to solve this? Okay, so this is okay. So how are we going to solve this? So we have BC, ABC, and the answer that we have to return is ABC. Why? Because it's all unique characters in here, and all unique characters in here. And suppose we take something that traverses elements from left to right, and we create some data structure as well that is gonna store them in lexicographical order. Now, two things here. What data structure I'm gonna use here that will store everything out of it and in one by one form, and it is also deleting everything. So only data structure that comes in my mind is what stack, right? So BC, ABC, yes. How are we gonna solve this? Int n is equal to s dot length, and we create a new string. Now this is what we call context. So this is going to be a stack of something, and are we also gonna create a map of something? Okay, so we can create a map of this. Now for this, let us see. Now, while this, so I'm going to get stack.pop, and while we do this, then if while stack.if is equal right. स्टैक ले रखा है, एक मैपिंग करना पड़ेगा। एक मैं नीचे कर देता हूँ, हैश में भी लेना पड़ेगा और एक हैश सेट भी लेना पड़ेगा, एक सेट भी लेना पड़ेगा। दोनों काम करने पड़ेंगे। तो पहले सेट की वैल्यू डालते हैं इसके लिए। तो फॉर electricity dot air array, then map dot put a dot get default -1। अब स्टैक की वैल्यू डाल दी, इसके अंदर हैश की वैल्यू डाल दी। अब फॉर यहाँ से नीचे करो, फॉर करेक्टर सी इज इक्वल टू दिस, ओके, एंड इसे यहाँ से हटाओ। नाउ अब मुझे यह चेक करना है that if for character then map dot put c dot get default -1 and if set dot contain c continue, okay। now stack c continue डाल दी and map dot contains map dot get stack dot p is greater than 0, stack dot pop नहीं, stack dot pop नहीं, visited versus stack dot pop, visited नहीं, stack dot pop, okay, and then simple stack dot push p and set add let's see। ABC, okay, ACDB BDCA O okay, SB dot to string, okay, so we have to reverse the string, alright, so we have to reverse the string, SB dot to string dot reverse, okay, SB dot string dot right, or just simple stack and sb dot attempt c, then you have c, okay, abc, okay, so it's just simple here, some simple checks in here, then if we do this All right, and that's it for today. Tomorrow we will be doing this shuffle string question. Okay, so yeah, that's it for today, and we will meet tomorrow for more questions. Tomorrow we will be doing some good ones. Today we did some easy ones. Tomorrow we will be doing some more ones. Let's mark the today's question. So and yeah, this one string rotation check, and we did all. Okay, let's just mark. Okay. All right. So we did this. Tomorrow we will be doing with shuffle and valid shuffle count and say longest recurring subsequence, then print all subsequence, split binary string equally, and mobile numeric boy mover weapon car. So tomorrow we'll be doing some. So tomorrow are very good questions. Okay. So tomorrow we'll be doing some good questions. And yeah, after I guess string would be completed. Maybe tomorrow. Yeah, tomorrow I believe that we can do strings, and after that we will be left with revision for Saturday and Sunday, and after revision we can continue on ahead with more of our work with hash tables. We will complete hash tables very fast, and then we'll complete with two pointers, and after two pointers we can convert with prefix sum. We have done some questions of these both, but we'll be completing them, then we cadence and all those things, so we'll be doing it in a very fast manner. Already, so this is from my side, and we'll meet again tomorrow, and please take care of yourself, of your family and everyone. And yeah, I'll just create a new one, what we call a revision mark. Okay, so we will do revision 1, revision 2, revision 3, and all those kind of things. We will revise everything. Okay, so that's it for now. We'll meet again tomorrow, and can we try this? Okay, let's try this. Okay, so suppose we take a new string called um, str. Okay, okay, is equal to empty. Okay, string str is what? Empty right now. Okay, we don't know what to do of it. Now for int I equal to 0, I less than indices dot length I plus plus. All right, so can we say that str dot indices of I is equal to s comma I. Hmm? And we can then return str. Let's see, str indices of I, put string found, array required, array of string formed. Okay, array required but string. Okay, string str is equal to new string, or new uh, new str is equal to new st string, and we'll call it s dot length. Right, string cannot be converted into string array. Okay, string array required but string found. Okay, s dot char at I, s dot char at indices of I, s dot. Okay, string str is equal to maybe empty, and string str dot char at this. Hmm? All right, Indices of I. Right. Okay. Okay. This is also wrong. Let's copy this. Okay, so there's some problem in net. Okay, let me just hold it for a moment. All right. str.char at indices of I. str.char at indices of I is equal to s.char at I. For example, indices of char at 4. ओके हाँ तो क्या दिक्कत है str.char at str.char at I indices of I int I is equal to 0 I less than length length okay minus 1 all right unexpected type str.char at indices of I indices of I indices of I all right wait a second return str now restore string uh, str.char at indices of I hmm, is equal to s dot char at I dot char at I. Oh, okay, okay. Hmm. Should we take like okay? So if we take maybe a character array str, okay, is equal to new char, and what is the length of it? It is length of going to be the same as indices dot length, okay? Because I have been told that this is what unique one. So let's see. So str now it's not going to take right. So str um str of of indices of I. All right, is going to be what s dot caret I and return str dot to okay. Let me just say convert char array to string in Java. Okay, how can we convert it using the static classic constructor string array? Okay, string dot str. Okay, return new string. Return new string. All right. All right. Okay. Uh, is it because of this? Let me remove this now. All right. Yeah, it worked. Let's just submit this. I think it was just taking care of issues. All right. So it's a good one. Okay. So we did this also. So I'll just mark this here, and tomorrow I'll just mark it on that one as well. So what is this? Valid shuffle and two strings. So tomorrow we'll be doing more questions on good questions on medium and hard ones on this. All right. So yeah, this one from my side, and okay. So take care, everyone. We'll meet again tomorrow. And yeah, this was a good question, right? Simple one. because we have to just take the indices of the array and then working it. You understand what we did here? You have a character array of str. We take a character array of str of same length as str. Now character array is what? Empty. Now if it is empty, then we are going to place positions which are given on the indices of I. So the indices of I. So for example, the indices of I is here 4 here. Now the 4 is what? Places on key here at C. So indices of I 4, str at fourth position is going to be what? S dot caret I, that is on the fourth position. So same on here. And then we are going to fix all array, then character array is what formed. And now we are going to return a new string, that is str. All right. So good question. Simple question, but good question. All right. Okay. So this count and say we'll do this tomorrow. We'll understand what this question is, and we'll just move ahead then. Okay. So thank you so much for watching this video, and all of you who have joined, who have not joined, maybe